Students, as we were discussing the increase in bandwidth, and we covered that due to applying the negative feedback, the lower cutoff frequency decreases and upper cutoff frequency increases. Totally, there is rise in bandwidth that takes place. The same is represented in this particular graph. Friends, we already studied the frequency response curve, and we know that it is nothing but the graph of voltage gain versus the frequency. And we are aware that the frequency response curve is divided into the three regions. One is a low frequency region, second one is a mid frequency region, and third one is a high frequency region. While deriving the formula for lower and upper cutoff frequency after feedback, we have considered all these aspects. But when the graph is plotted, here is the graph which represents, so this one where the gain is maximum, gain is more, this represents the frequency response curve without feedback. That is, here it is written as AV. So it is the gain of amplifier without feedback. And for that frequency response curve, we have a lower cutoff frequency as a F1, which we already considered during the derivation, and upper cutoff frequency as a F2. We know how these are going to be gets plotted, and we have given the definition that F1 is a lower cutoff frequency in low frequency region, and F2 is the upper cutoff frequency in a high frequency region, respectively, where the respective low frequency and high frequency gain falls by an amount of 0.707 times the mid frequency gain. So this is the fall of mid frequency gain. From this, a straight line is drawn. From that, the perpendiculars are produced on the frequency axis, and then we have represented the lower and upper cutoff frequency F1 and F2 respectively. When we take F2 minus F1, that is going to represent the bandwidth. Friends, from F2 to F1 represents the bandwidth without feedback. But if same graph is plotted with feedback, means this is the graph which we have obtained. This clearly indicates that voltage gain here it is less than that of voltage gain without feedback. That is the first thing, which is the property of the negative feedback. Another aspect is that for this particular mid frequency gain, when we calculate the lower cutoff frequency and also upper cutoff frequency as a F1 dash and F2 dash, that is here. Here is the fall of mid frequency gain that takes place, and from that a straight line is drawn. From the point of intersection, we have drawn the perpendicular on the frequency axis in low frequency region as well as in the high frequency region. We obtained the respective frequency as F1 dash and F2 dash. If you look to F1 dash and F2 dash, here it is totally clear that F1 dash is less than F1 and F2 dash is more than that of F2. Thus, the difference between F2 dash and F1 dash, that means this frequency range, it is called as a bandwidth after feedback. If you look to both, bandwidth after feedback seems to be more than that of bandwidth the before feedback. This is how we can say due to applying the negative feedback, there is a rise in bandwidth that takes place. Friends, this is in continuation with the derivation of increase in bandwidth due to application of the negative feedback.